Okay, so good afternoon. I've got the after lunch slot. I hope your lunch has been good and that you're now ready for a good sleep. I made sure that I had my lunch 5 minutes ago. That's my time management skill. 5 minutes ago, so my carb slump will not kick in until the end of my talk. So I think that I've managed my time very well indeed. So, as Dylan says, I'm going to talk about architecture as knowledge. There are lots of ways of looking at this thing. I'm not really going to explore the architecture metaphor itself. I'm going to assume you already have some ideas about software architecture. It's a topic that I have quite a lot to say and reflect on. But I want to focus on the idea that architecture is literally codified knowledge. Your code base is literally codified knowledge. It is a codification of all the things that you collectively, over time, as a team, and as customers and product owners and the organization you're within, that you believe and have believed, okay? And it's executable. Executable belief, okay? So that normally means something different. So my name's Kevlin Henney. I'm an independent consultant, trainer, writer, etc. And thanks to the fragmentation of social media, for which I thank Mark Zuckerberg and Elon Musk, it was all going so well. But we've now it's now all fallen apart. You can find me in most places. But I'm going to start with a recognition that most of us are problem solvers. So I'm going to give you a little problem. I don't want you to solve it now. But I recognize this is after lunch, so I'm going to give you the problem, and then we'll come back. I'll reintroduce it later, okay? So I'm going to talk about a library system. Now, a library system is one of the oldest examples in software development for training. I think it dates to at least the 1970s. People have been taught this on courses and at university as an information processing example. It's relatively timeless. So timeless, in fact, that a chap that I was working with a number of years ago, so this is around 20 years ago, he saw that I was preparing another session where I was using the library. And Paul said, libraries, yeah, Kevlin, that's so old-fashioned. You've got to keep up with the times. You see, he says, I've now switched to using a video rental store. Yeah, how'd that work out? I had to explain to my 17-year-old what a video rental store was. He was absolutely shocked. It was when we were walking past an old shop, or rather, a new shop, and I said to my wife, do you remember when that was the video rental store? We used to go to the pub, go and get a video, and then go and get a takeaway. And obviously, after a few drinks, the selections that you make for both your takeaway and your videos are top. They're excellent. But my son was there. He was just like, what, hang on. How, you mean you went to rent videos that other people had touched and used? Yeah. What happens if the one that you wanted to watch was not there? Then you chose a different one. He was shocked. It was like we were living in the Stone Age. Now, there's a point here about time and timelessness, and that is actually very much the theme of what I want to talk about. So, the library system. A couple of actors. You've got a member. You can join a library. They can borrow up to 10 books at a time. They cannot borrow any more books if they have books that are overdue. A book loan lasts for 4 weeks before it becomes overdue. When an overdue book is returned, the member is fined some amount, maybe 20, 25 cents a day. They can pay off part or all of their fines, and they can renew a book. They can renew a loan up to 3 times. I didn't finish it. I didn't make much progress, so could I just renew my loan? Okay. Then we've got the librarian, the administrator of the library, and they're responsible for registering new members for the system as well as new books. Okay? This is the stuff that already exists. I'm going to simplify things massively. I'm going to say this is a fancy way of saying I don't want you to worry about databases. So what I've said is it's an in-memory object-oriented database. Fantastic. In other words, it's just the objects in memory. That's a kind of... And I'm going to let the operating system and all our other systems deal with security. I'm just going to strip this right down. There are some things in the backlog that we want to deal with. Potentially, in future, we want to support child membership, some differences in terms of payment and things. We want to add a reference section to the library. You often find this in university libraries and in central libraries, that you can go into the library, you can look at the book, but you cannot borrow it. You can only use it whilst in the library. We might support additional member services, email access and other services we can offer to people. We might go wild and embrace the early 21st century and go for DVDs and Blu-rays. You know, there's other things that we can actually lend out. And we can allow members to reserve books. If they want to borrow something and it's not there, then they can reserve it in advance. And there's a bunch of other stuff, but I'm just going to focus on these 5. There is kind of a simple kind of model here. We've got a library, there's a membership, there's an object responsible for membership, deals with members. We've got loaning, loans, catalog deals with book copies and the actual titles, the catalog entries. Now, of course, there's going to be a lot more classes than just 8. I want you to imagine that you've got all your kind of little helper classes, your value objects, your exceptions, all this other stuff. But I'm not going to focus on those. I'm just going to focus on the kind of principal entity and aggregate types here. So my question to you is, I don't want all of this in one package or one component. And I've got 2 ways of partitioning this. I can organize it, as it were, horizontally. So I've got 3 packages there, or I can organize it like this, more vertically. Okay? That's 2 choices. It doesn't actually make any difference to the runtime object model, but it makes a difference to how you organize and how you think about your source code. And I'm going to emphasize, I'm going to focus very much, we could later chop this up into microservices and all the stuff, but honestly, let's not make things too hard. Let's just focus on the basic partitioning. How would you put this into namespaces, packages, modules, whatever your language offers you? Okay? There's the feature backlog. That's the question. We'll come back to this. So I want to go back to the past. I'm going to quote Grace Hopper, one of the people responsible for the invention of the compiler, basically. And she was a woman of wisdom and a very sharp sense of humor. But I want to focus on her wisdom here. To me, programming is more than an important practical art. It is also a gigantic undertaking in the foundations of knowledge. That's, as I said before, you are codifying knowledge. You are trying to find out what's the knowledge you have to deal with. You have to deal with what are we trying to build? And you're also dealing with how are we going to build it? And then you're dealing with all of the uncertainties and shifts in changes all around that. You're trying to capture this knowledge. So knowledge is the stuff that we work with. We are effectively knowledge workers. I used to have a very poor view of this term, knowledge worker. I thought it's just a kind of made-up HR term. But actually, it's very true. You work, that's your tool set. But the thing you also have to recognize is you have incomplete knowledge. You are always working with incomplete knowledge. The knowledge that you need for the job you are doing today, the knowledge that you need lies in the future. In 6 months' time, you go, oh, we should have done this. Okay? If only you had access to that knowledge. Disappointingly, outside of science fiction, we do not yet have a way of short-circuiting this. Is that a problem? We are never going to have complete knowledge. We are always, we are always working without everything that we need to know. I have some very good news for you. You're a human being. Just a reminder, hopefully you already knew that. You're a human being. What does that mean? It means that working with incomplete knowledge is one of your superpowers. You get up every morning without knowing what the day will hold for you. I mean, you might have some idea, but if you knew exactly what was going to happen, you wouldn't bother doing it. Like turning up to this talk. If you knew exactly what I was going to say, then why bother turning up? Because you have the knowledge. The point there is you get up every single day with incomplete knowledge of what the day holds, and well done, you reach the end of the day. Result. Congratulations. You can do. Humans are incredibly good at working with incomplete knowledge. Our weakness, however, is when we fool ourselves into thinking that we have complete knowledge. That's the problem. It's not the lack of knowledge, it's kidding ourselves that we know enough. And we make plans. And then we stick to the plans. We offer estimates, and people hold us to those estimates that were made with incomplete knowledge. And that works against us. But working with incomplete knowledge, that's a superpower. So we also must recognize that there are limits, inevitable limits to our knowledge. Some things we can never know. Douglas Adams wrote Hitchhiker's Guide to the Galaxy, made the number 42 ridiculously famous. There's a lovely scene in it where it talks about the idea of philosophers demanding rigidly defined areas of doubt and uncertainty. And you know what? We see that. Who here has code that relies, or a system that relies on the network in some way? Please raise your hands. Yeah. Rigidly defined area of doubt and uncertainty. You don't control the network. The network often becomes a not work. It has latency, it has jitter, it has failure. Any question you have about the network is answered with it depends. And maybe, or who knows. You don't control it. There are consequences to this. Yeah, it is normal for a distributed system to fail with some interesting consequences. So my publisher, O'Reilly, had a bit of an outage. In fact, often has an outage whenever there are fires in California. You can't read your ebook. Wait a minute. That's annoying. Now, that's the point. We build distributed systems. Another publisher, a number of years ago, published a couple of books I co-authored on pattern-oriented software architecture. And this particular one, Pattern Language for Distributed Computing, we had a definition of what we meant by a distributed system. A distributed system is a computing system in which a number of components cooperate by communicating over a network. I mean, that's not wrong, but it's quite a boring definition. I much prefer Leslie Lamport's definition. A distributed system is one in which the failure of a computer you didn't even know existed can render your own computer unusable. Now we know. You see, the previous one, that's an intellectual definition. This one is a definition for the heart, not the head, okay? You know what this feels like. And we formalize this in a variety of ways. CAP theorem from Eric Brewer actually is a theorem. It was originally a conjecture, but it's been proven. It was proven about 30 years ago. Anybody familiar with the CAP theorem? Raise your hands. Okay, there's a few people. Yeah. Consistency, availability, partition tolerance. Let's just call it tolerance. Makes a cat theorem, so that's much more interesting. There's cats on the internet. What that says, consistency for your data, consistency, availability, and tolerance, you can have any two. You cannot have all three. It is effectively the Heisenberg uncertainty principle for the network. And the Heisenberg uncertainty principle is baked into the universe. It is a rigidly defined area of doubt and uncertainty, as is anything on the other side of an event horizon. The universe, it's not just software developers that have boundaries to their knowledge. The universe also offers these, as indeed does mathematics. There's a bunch of stuff that cannot be known. So, observation that may or may not have come from Socrates, I know that I know nothing. We need to organize our knowledge. What does that mean in practice? I'm going to use a scheme that comes from Philip Armour. He wrote about this in Communications of the ACM in 2000. Sensibly enough, he organizes his 5 orders of ignorance. He organizes 5 orders of ignorance, starting at number 0. So well done. I'm already impressed. Lack of ignorance. You know that you know something. Okay. I know that I can speak English. I know that I can't speak Lithuanian. Lack of knowledge. I know that I don't know something. Okay, it's not a surprise. Lack of awareness. Now it gets interesting. Lack of awareness. You don't know that you don't know. This is where surprises happen. This is where, as it were, assumptions are revealed to be wrong. Oh, I thought, no, that's not the way it is. But I've always been taught that, yeah, it turns out that's not the case. Lack of process. You can't find out what you don't know in advance of it happening or being relevant. There is no way to do this. And then there's meta-ignorance, which is you don't know the 5 orders of ignorance. Well done, we've solved that one. So just take that one off the list. We've got 4 orders here. Now, I'm going to borrow that kind of phrasing from Donald Rumsfeld about the unknown unknowns and kind of characterize it. The known knowns, the known unknowns, the unknown unknowns, and the unknowable unknowns. Occasionally people look at this and they want to mess the words around and go, Kevlin, you missed out the unknown knowns. No, those are the unknown unknowns. The unknown knowns, people say, yeah, but the things that you thought were right but are not. No, you just always been wrong, you didn't know it. That is an order 2 thing. You had a lack of awareness. Don't try and dress your lack of awareness up any other way. Okay, so it gets interesting. It gets interesting because a lot of what we need lies in the future. And there is this observation that prediction is very difficult, especially about the future. What I like about this quote is it's a humbling reminder that the past is already difficult. What do I mean by that? We don't know who said this. I like to think that it's Niels Bohr, because he was a quantum physicist. Okay? And so therefore the whole kind of like uncertainty around this and the idea of this kind of works for me. But other people have said other people. In fact, we actually had this compromise in one of the books that I co-authored. One of the other 2 authors said, no, we're going to use Yogi Berra rather than Niels Bohr. But in another article that I published, I've used Niels Bohr. So I've played both of these. Here's the point. If we don't know who said this in the past, and the past has already happened, what hope have you got of predicting the future? Just keep reminding yourself, okay? Now, there are implications for this. And these implications are quite big. Because Grady Booch, there's a number of definitions of software architecture, but here's one that I often use from Grady Booch. Architecture represents the significant design decisions that shape the form and the function of a system, where significant is measured by cost of change. The problem is you don't know this in advance. You don't know what the significant design decisions are. You know some of them based on your experience, but you don't know in advance necessarily everything that may or may not change and what in the way in which it will change, and what's that going to cost you? You don't know. Now, sometimes we can substitute the word, we can take cost, we can substitute other words. It's going to take time to do this. It's going to take effort. It's going to be painful. That's the other way of measuring architecture. How painful is that change? Yeah? Oh, this is going to hurt. Okay, that's an architectural decision. So Randy Schaub at, I think Build Stuff 2019, he made this observation. If you don't end up regretting your early technology decisions, you probably over-engineered. He is basically saying that there is an inevitability. Don't fight it, embrace it, take advantage of it. You're working with incomplete knowledge. That's okay. As long as you're okay with that, then you are not expecting everything to be perfect. And if you try and make everything perfect, it will be even less perfect. Yeah, there's a paradox there. I also like Ralph Johnson's observation. Architecture is the decisions you wish you could get right early in a project, but you're not necessarily more likely to get them right than any other. Those are the decisions where in 6 months' time you go, oh, I wish we had done this 6 months ago. And yet you cannot find that time machine. So you're stuck with it and the pain that it brings. Okay, now who's Ralph Johnson? Ralph Johnson was the 3rd author of this book that helped popularize a very particular idea, design patterns. Gamma, Helm, Johnson, Vlasides, the Gang of 4. A lot of people have got trapped in their understanding of design patterns. They think that this is the book that defines design patterns and everything you need to know. Anybody who's come off a university course where they taught you design patterns, I have some very bad news for you. Your knowledge is almost worthless. Because it turns out that this book is not everything you need to know about design. It is merely a subset of patterns. It has 23 patterns. The book I showed you earlier had 114, and we referenced another 200. Because what is a pattern? What's a pattern? Pattern is a distillation of knowledge. And so there's an interesting point here about understanding they didn't introduce patterns into software development. There's some really good stuff, and this was when this book came out, I was just like, this is amazing. It really characterizes stuff. I had not seen any book that was occupying this space. But it's 30 years old. We've learned a few things since then. But it has a prehistory. The prehistory starts here. Look at the, if you look at the URL, you understand 1993, that was 5 or 6 years after patterns were actually introduced to software development. Kent Beck and Ward Cunningham. Kent Beck, who's typically associated with extreme programming, test-driven development, JUnit, and stuff like that. Ward Cunningham, who basically invented the wiki. And they introduced this idea. They said, we propose a radical shift in the burden of design and implementation, using concepts adapted from the work of Christopher Alexander, an architect. Okay, that's pretty cool. And Alexander had created a catalog of 253 patterns for designing and organizing everything from your nation state down to where you place your furniture in your house. That's scaling. That's scaling. He touched both ends of the scale. And this is a hell of a book. It's 1,000 pages long, but it's very, very 1970s kind of feel to it, but it's a lovely book. And Kent and Ward highlight, Alexander encodes these bits of knowledge in written patterns, each sharing the same structure. The idea of trying to communicate experience. How do we build a pleasant place to live? How do we structure a nice urban environment? How do you make your house look interesting and good, and not just like you visited IKEA? I'm not knocking IKEA. It's how do you make it look that you didn't just visit IKEA? Yeah? How do you make it your home? That's the question. Oh, back to something else. I like IKEA for a number of reasons. One of them is it allows you to make mistakes. Yeah, you can change things and move things around. It's a lot easier. That's that kind of fits my kind of approach to building things. Each has a statement of a problem, a summary of circumstances creating the problem, the situation, the context, the forces that arise from that. Most important, a solution that works in those circumstances. The idea here is an important one. It's a description. People are often miss. They think, oh, patterns, that's just kind of like a bunch of object-oriented design stuff. No, it isn't. And anybody who tells you that, get them to email me, yeah? Because it's like, oh no, patterns are about object orientation. Let me think. Yeah, this is a book full of OO design. No, it's not. Patterns are not about that. They are about knowledge. The reason people often associate them with OO design is that's where they were popularized, but don't confuse the fact that they became popular with that with that that's all they're about. They are about knowledge and how we organize that. So, Alexander notes, each pattern describes a problem which occurs over and over again, a recurring. That's the point of the name. We've seen this problem before. We've seen solutions to it. But the point about it is the core of a solution. And you can implement and use that same idea in many different ways. Each time you go, oh, I'm reusing knowledge. Occasionally I get somebody emailing me, hey, you don't need design patterns, here's my framework. I think that's very sweet. Again, get them to email me if they actually think that. I think that's one of the, when I run a patterns workshop, I've got a number of newbie mistakes, and that's one of them. It's like, no, I've captured all these patterns in a framework. You'll never need to worry about patterns again. Oh, that's really cool. So what's your framework written in? JavaScript. Okay, so how am I going to use that from C? Oh, no, you can't call it from C. But can I use the ideas in your framework? Well, yes. That's a pattern then, isn't it? It's the reuse of ideas, not source code. So what we're talking about here is reusing experience and communicating. That's what patterns are. You can't actually make much money out of patterns. I know. Because the point here is that you're trying to communicate knowledge. You're not creating product. You're simply distilling and organizing experience for other people. A capsule definition of engineering, independent of any discipline, as you're likely to find. This is an observation from Glenn Vanderberg. What do we mean by engineering in this particular case? And it's very much the patterns aesthetic, the set of practices and techniques that have been determined to work reliably through experience. Patterns are empirical, they are experience-based. If patterns had a manifesto, which it doesn't, but I remember writing this when I was running a patterns workshop for a company a few years ago, I said, if patterns had a manifesto, it'd be really simple. We are uncovering better ways of developing software by seeing how others have already done it. That's the whole point of patterns. As Brian Foote, a member of the patterns community, said, patterns are an aggressive disregard of originality. The whole point of a pattern is it's not original. When somebody says, I've invented a new pattern, no, you haven't. You've invented a new design idea, but until other people make independent discoveries or start applying that idea in slightly different contexts, it's a great design idea. You can't invent the pattern in that sense. The value is in the idea. This is also one reason why you also get academics not really being into patterns, because the reward system for academia is originality. All you're doing with patterns is documenting things that people have already done. And your skill is in trying to document it and communicate it well. You're trying to communicate experience, which is a very hard thing to do. Now, there is a question here. Not all patterns are created equal. Not all patterns are necessarily good. In this book, The Timeless Way of Building, kind of one of my favorite books on architecture by Christopher Alexander, where he really describes the patterns philosophy and patterns approach. He tells us how to assess whether or not a pattern is good. Now, a lot of people may be familiar with the idea of anti-patterns and stuff like that, and that's kind of all a bit stuff we've invented in software because we didn't read the original book. Anti-patterns makes it sound like it kills off patterns like antibacterial or anti-aircraft gun. That's not the idea. And we also use other terms like smell. That's for... Honestly, sometimes you just got to read the original Alexander. He used really complicated vocabulary. He said patterns can be good or they can be bad. He didn't use the word anti. He just said it's bad, it's not good. So how do we know that it's good? Again, let's talk about something empirical. We say that a pattern is good whenever we can show it meets the following two empirical conditions. One, the problem is real. Now that seems obvious, but you're a software developer. How many times have you, or your, no, let me displace this slightly to make me feel more comfortable. How many times has one of your colleagues spent a lot of time solving something that wasn't actually a real problem? It was a problem in their head. Imagine, and this is the problem. I'm not saying that we shouldn't think about these things, but you have a real problem. If you have a good imagination, you will never deliver. The better your imagination, the more problems you can imagine that you need to solve. If you have a poor imagination, you deliver on time. That's a terrible paradox here for a creative profession. The problem is actually real. It does exist in the system that we're working in, the situation that we're at. Let's just have a reality check. Let's not spend our time solving problems that we don't have. We can anticipate, but be careful what you do with that knowledge. The configuration solves the problem. Now, I need to clarify, if English is not your primary or your mother tongue, then as you're a software developer, you have come across the word configuration in a very specific context. This is not that word. This is the general sense of the word that means an arrangement of parts, which is indeed where software gets the whole idea of configuration. But I'm going to shift this slightly, because I don't want, this is what he evaluated as good is not unique to software. Oh, sorry, is not unique to patterns. It is about design decisions. We say a design decision is good whenever we can show it meets the following two empirical conditions. The problem is real, and I've changed the wording. The solution solves the problem. Again, that one seems really obvious. But again, you or one of your colleagues, how often have they done something and actually it hasn't solved the problem? It's created a new and exciting problem. Yeah, it's just like, yeah, but the code's really complex. Yeah, but now we can configure it for the future and stuff like that. The future arrives and it looks completely different, but now you have a lot of code complexity and unmanaged technical debt. Okay, so let's talk a little bit about time and architecture, and I will also use this to present a pattern. So this is actually a book about architecture. Stuart Brand, How Buildings Learn. And again, that idea, learning is a system of knowledge. I also find it interesting. This book came out in the 90s. It actually inspired a number of people in the software space, and particularly the software patterns community, to take the ideas, again, from architecture and see, do we have parallels in the world of software? The idea that building architecture is not static. A lot of people think building architecture is static. No, no, no. If you look at old pictures, these are 150 years apart, you would not recognize these as being the same building. Architecture is about change. Architecture is not about not change, it's about change. It just happens that buildings evolve over different timescales to software. Buildings evolve over timescales that are comparable to a human lifetime. Software evolves over evolves over a kind of timescale that is comparable to a Monday. So there's a difference of rate, but building architecture is about change. And Brand makes an observation based on the work of the architect Frank Duffy about layers of change. The idea that you want to organize is organize your architecture in terms of the things that naturally are volatile versus stable. So for a building, the most stable location is its foundation, its site. That very rarely changes. Occasionally, does anybody from Romania here, by the way? Okay, yeah. Ask a Romanian about moving buildings. Ceausescu was very into this during the communist era, would move a building because it just wasn't in the right place for his grand plans of what places like Bucharest and elsewhere should look like. So they would actually move whole buildings. Romania is the moving capital of the world. No other country has moved as many buildings. The rest of us think a building just stays where it is, and it normally takes an earthquake to move it. But let's just say, apart from these exceptions, the site is the most stable part about a building. Then it's load-bearing structure, the bit that actually holds up the building. Then it's skin, it's facade. The skin or facade of an office building typically has a life cycle of around 30 to 40 years before it changes. And then there are the services, the lighting, the electricity, the cabling, all of that kind of stuff. That has a 5 to 15-year cycle. And you can start seeing why you want to organize a building according to the layers of change. Because if you keep changing your cabling and your services, you don't want to have to rip out the load-bearing structure. That's expensive. So you make sure that you have structure. This is why, in fact, this room also has it. You have false ceilings and false floors and even false walls, because it makes it easy to change the services and cheap to change the services. You respect the fact that the building is going to last a lot more time, as it were, than the things you put through it. And then you have the partitioning of the space, the non-load-bearing stuff, and then the stuff, the chairs, the tables, that can move on a daily basis. So the lesson here, by the way, let's just be absolutely clear. I am not suggesting that on Monday you walk into your office and say, okay, I was at Build Stuff last week, I saw this talk, and there's a really interesting idea about architecture. What we need is to turn our architecture into a 6-layer architecture where every layer begins with the letter S. That is not the lesson. Let's just be very clear about that. The lesson was captured in a pattern, very nicely by Brian Foote, who I mentioned earlier. Patterns are an aggressive disregard of originality. Shearing layers. Different artifacts change at different rates. So this is a summary of the whole pattern. It takes a bit longer to describe it. Therefore, factor your system so that artifacts that change at similar rates are together. And you can use historical data. So there's a wonderful book by Adam Thornhill. Second edition is coming out in January. Your code is a crime scene. Very much code analytics. Let us understand our code base by seeing what has actually happened. And Adam makes the observation, measuring change frequencies is based on the idea that code that has changed in the past is likely to change again. You're looking at trends. You can't predict the future, but you're going to be a little better off predicting the past. So what has continually, repeatedly changed? In fact, this is a very positive thing. I want you to think about this from a legacy system point of view. The great thing about a legacy system is that it has history. The bad thing is that we often don't use that history. We have a whole record of the past, what actually happens rather than what we think happens. There's all this evidence lying there as to what really changes versus what doesn't. And we should use that. So, let's talk about one of the difficulties we have in making design decisions. Michael Nygaard captured this very nicely. So over 10 years ago, one of the hardest things to track during the life of a project is the motivation behind certain decisions. A new person comes to a project, may be perplexed, baffled, delighted, or infuriated by some past decision. Without understanding the rationale or consequences, this person has only two choices. One, blindly accept the decision. That's the standard, we fear what we do not know. Okay, don't change it. Just work around it. Even if it shouldn't be there anyway. Or blindly change it. That's the symptom of overconfidence. I know better. And you know, sometimes you do. And sometimes you don't. Sometimes there's a really good reason that it's like that. Better to avoid either of these. We will keep a collection of records for architecturally significant decisions. This is ADRs. Anybody use ADRs? Okay, so a few of you, oh, that's really good, yeah. Architecture decision records. Those that affect the structure, non-functional characteristics, dependencies, interfaces, etc., or construction techniques. The idea is that an ADR is simply a record. It's not a big fat piece of documentation. It's lightweight. In fact, some companies I've encountered, they kind of miss the message on the lightweight thing. But here it is. An architecture decision record is a short text file in a format similar to an Alexandrian pattern. That's the point. He's taken this idea from patterns. He's not using it to talk about recurring ideas. He's using it to talk about this kind of problem-solution context arrangement. He's using the very structure. In fact, the word record itself is an indication of how long it should be. Had he meant write large documents, he would have called it an architecture decision document. Now, why am I emphasizing this? Well, a client of mine said, oh, yeah, we're using ADRs. I said, oh, OK. So you're writing them in Markdown, and they live alongside your code. And they're all nice and short. Basically, they're kind of, the kind of thing that you can casually write notes to yourself in. The idea is we're lowering the barrier to entry. We don't want people writing big documents. What we want to do is the kind of stuff that you would write on a whiteboard or just simply in a text file. And importantly, take the ceremony out of it. Oh, no, they weren't doing that. No, we keep them in SharePoint, completely separate from the code. And then they said, here's an ADR, and it was 8 pages long. There is no way that that qualifies as a record. A record is, those little cards, those are record cards. That's why he used this metaphor. Each record describes a set of forces and a single decision in response to those forces. The decision is the central piece here, so specific forces may appear in multiple ADRs. OK, so remember this? Yeah, just keeping you awake. Good. For those of you that arrived late, I showed this at the beginning, but quick catch up. It's a library system. OK, there we go. That was easy. Here's a simplified view of its model. What's the challenge? How are we going to organize it? OK, we're going to partition this code. We can do it like A or B. Here's the stuff we know, or kind of know, because we don't know the future. This is the backlog. Things can change. Which packaging would be best or most appropriate for the library? So can I get people who think A to raise their hands? So I've got a couple of people. People who think B to raise their hands. OK, well, for once, the majority is actually correct. Well done. B. But why? Why is the question. Remember, both will actually work, but why am I saying that this is better? Well, structurally, what we can do is I can show you how everything's arranged. You're going to end up like that. OK, that's kind of nice. But now I'm going to write an ADR. I'm going to write an ADR to tell you why I made that decision, why I'm justifying this way. I'm going to partition packages according to subdomain. That's what we're doing. We're saying there's loaning, there's membership, there's catalog. I'm going to call these subdomains. There's a context. We are developing a library system and have an object model that contains classes for members, loans, book copies, and so on. The core of the model, plus library and associated aggregate management, and so on. We can package according to technical role or layer in a system. So option A was the technical role structure, as in this is a manager, this is an entity, and so on. Have a manager layer above the entity layer, or we can package according to the subdomain, membership, loaning, and catalog. Decision, we partition the packages vertically according to the subdomain, because this is the most likely to localize changes already found in the backlog. Now, I can't predict the future, but what I can use is a probabilistic approach. What you do is you say, well, either you have data from the past. I gave you no data from the past for this system. Well, how do we get data from the future? Well, you don't. You get probabilities from the future. Now, let's see, the quantum mechanics thing comes back again. I can't tell you absolutely that this is correct, but on a balance. Oh, hey, actually, wait a minute. I'll give you a simple one here. What's tomorrow's weather likely to be? Similar to today, yes. There is a roughly 70 to 75% chance that tomorrow's weather will be like today. That means that all those amazing supercomputers that are used for meteorology have to do better than you looking out of your window. OK? Now, I'm not predicting the future. That's why in English the word forecast is a softer. For prediction is a very strong word. Forecast. There's a 3 in 4 chance that tomorrow looks like today. There's a 1 in 4 chance it won't be, which allows the weather to evolve. But that's what we're doing. Given what we know, can we make a probabilistic approach? Yes, we can, based on the changes in the backlog. And then the status, this is the decision we've accepted. And then the consequences. Local package and therefore deployment stability in the face of most anticipated changes. Great. Some responsibilities can be easily moved from entity to aggregate. Where you do validation, is that going to be in the entity object or the aggregate object? If you want to validate whether a loan is acceptable, do you do that in the loan object, or do you do that in the loaning object that initiates that? Honestly, I don't care. And changing your mind is a local decision to that package. That decision does not cross packages, does not cross layers. However, there is a cyclic dependency between the packages. That is a consequence. And if we change our approach to doing managers or aggregates or entities, then that will change everything. If we have a change in our approach and our philosophy, so an underlying technical, if there's another ADR for how we build these things, then we accept that. So notice I'm not listing just the good things. I'm listing also the things that may be a problem. If anybody ever gives you, when they justify a decision, if they only ever give you good things, tell them to take a break and go and find the bad things with their design, because they're just selling you something at this point. They have not, if you do not understand that a design decision has boundaries and consequences, and that may not be good in all circumstances, then you have not understood that design decision. But here's another thing. I've also documented the decision that I didn't accept. I know a lot of people don't do this with ADRs. We actually spend quite a lot of time in this book talking about alternatives. That's the key thing. I've listed this one as rejected, partitioning packages horizontally according to the technical role, the relative layer in the code. I've reframed the consequences that are so they're specific to this decision. They're very much a mirror. But the idea is that we explored this when we were talking about patterns, that sometimes you have competing patterns in the same space. They're not the same pattern. They are different decisions. It's worth recording them if you have enough detail. So we kind of talked about this in terms of the idea that patterns can capture a narrative, a story of your system. Pattern stories are like the diaries that tell their readers the development of an entire software system, a subsystem, or large component. Yeah, the pattern stories discuss the problems that were resolved in the order that they occur during construction. So this is the idea that now if you're version controlling your ADRs, you don't mix your ADRs, you just change, you evolve them just like you do your source code. You can tell a story of the system. Okay, so we're going to close with another question. This is our package structure at this point. Let's ignore the classes. As you can see, we've got these cyclic dependencies. That's kind of annoying. Okay, it basically means whenever you have a cyclic dependency between two things, it doesn't really matter if you have a cyclic dependency between two classes, if they are in the same package or the same module or the same part of the system. That's localized. But if you have them between significant boundaries, whether that be package or component, then that's annoying because you don't really have two things. You have one thing broken into two, but it still behaves as one. If you update one, you have to update the other, and vice versa. A layered system, you have to update only one in one direction. So I'm going to give you another choice, but I'm going to give you less preparation for this one. We can rearrange it, so we're going to ignore the classes. Don't worry how we're going to do this. Do we want our system to look like this, where members depends on loans, depends on catalog? Main depends on everything, so we're not going to worry about it. Or do we want the catalog to depend on loans to depend on members? Option 2. Option 3 is, do we want members and catalog to depend on loans? Option 4, do we want loans to depend on members and catalog? Yes, it does. But I'm not giving you that option. It absolutely does. And it depends on what. Or rather, I'm going to ask you, let's do this statistically. I'm not going to, but let's be very clear, I'm not going to do this democratically. Because if you're wrong, I'll tell you. Okay, so can I have, option number 1, please raise your hands. Who favors design number 1? I've got a person there. 2, excellent, right. Option number 2. Oh, sorry, my bad. You know the right answer now. Okay, now, without telling me, were you going to choose 3? No, you weren't. Most of you are going to choose 4. Yeah, is that right? Yeah, most of you are going to choose 4. Yeah, that's my fault for putting the builds together on the slide at the last minute. Oh my goodness, it's option 3. Who knew? Okay, there we go. Right, why am I justifying option 3? You see where I put the little crosses? This is all the places that are likely to change based on our anticipated knowledge. It's exactly the same. So if we look, loans is actually the most stable thing, according to our understanding. Loans is like to experience the least change. So we order with respect to change or anticipated change. We are using speculation, but we're not using it to complicate the system. In fact, I'll show that in a moment. So I've got an ADR for this. I won't go through it because we're short on time. Structure package dependencies with respect to rate of change according to existing backlog. Notice the name. It's very specific. A lot of people don't write specific names for their ADRs. They do something like, oh yes, package dependencies ADR. That's a terrible name. Most ADRs I have ever seen and have ever been presented are terrible. If you do not understand why, then remember, it's a decision. Don't tell me about the decision. What's your decision? We're going on holiday. Yeah, but what's your decision? It turns out going on holiday to Spain is a very different decision to going on holiday to Australia. That's 2 different decisions. It's not the same decision. Be specific. So people, that's the weakness. So those of you applying ADRs, guess what? You do have work to do on Monday, because I'm betting that your ADRs are vague and poorly named. Okay, anyway, let's skip this. So I'm going to wrap up with, how do we do that inversion? How do we get the arrangement to look like it does? Well, if we took it just as it was, member depends on loan, loan depends on member, loan depends on book copy depends on loan. What we do is we invert the dependencies. We also allows us to find new roles. What we do is we localize and discover, you know what, loaning is a fundamental concept. Now, we could have discovered this by exploring the domain, but we've discovered it via a different route. We've also identified roles. The idea that a loan is an arrangement between a borrower and a loan item. There isn't a convenient word in English. Sometimes people use things like loanable or borrowable, which is difficult to say, so always make sure that you've checked how to say a word. But loan item is actually kind of the neutral term. So what we've got there is a structuring. From the point of view of code, and the important thing here is we are avoiding speculative generality. What happens to the code? So I'll just show this in Java. If you read this in C#, all you need to do is change the case of a few things, and it still works. Okay, so string has a lowercase s, and I'll just change the method name slightly. Most of the rest kind of fits together. Now, this is the code as it was. What happens when I localize those changes? Oh. I have added no new executable code. This is the important thing. We are not generalizing by adding loads of constructs. The difference between these two is the declarative construct. I have added more declaration. That's the only code. What I've done is I've arranged the boundaries and made my boundaries explicit. So when people say, oh yeah, but Kevlin, your approach takes more code, if I'm looking in terms of executable code, no, it doesn't. If I'm talking in terms of declarative code, then yes, it does. If you're using a dynamic language that has no kind of type concept that you make explicit, then no, it changes nothing whatsoever. Which brings us to the end, and the need for coffee. This is, I've shown already a couple of books on actual architecture. One of my favorite books here, 101 Things I Learned in Architecture School by Matthew Frederick. I like this book because it kind of makes you look, this is one of those books, Christmas is coming, by the way. It's one of those books, put it on your list. One of those books that makes you look smart and cultured. It's when your colleagues go, okay, they're not just a software developer. It's got a nice aesthetic appeal. And half of the advice is good for any design-based discipline. And he observes properly gaining control of the design process tends to feel like one is losing control of the design process. Yeah? Accept the fact you have incomplete knowledge and just lean into that and work with that. It turns out you can do a lot. Thank you very much.